In this video tutorial, I'm going to look at hbase. hbase is a NoSQL database. It stores data in a name-value pairs. HDFS is predominantly write once and read many times kind of storage. hbase is built on top of HDFS, and in hbase you can do read and update, and also you can append new records. So firstly, let me look at the POM file. So in the pom.xml file, you need to have the hbase client, and also here I have defined a couple of repositories. The first one is the Maven repositories, which is at repo1.maven.org, and the next one is a Cloudera repository. And hbase version here is defined as 1.2.0 CDH 5.83, and towards the end there's an hbase entry here. So group ID is org.apache.hbase and artifact ID is hbase-client. So once we have defined this in the pom.xml file, now I have got two Java classes. One is to write to an hbase and the other one is to read from hbase. So before we start with the code, I'm going to go into the Cloudera manager, and in the Cloudera manager you need to make sure the hbase service is running, and also the HDFS must be running because the hbase is built on top of HDFS. In the local mode, the hbase can also run in the local file system, but HDFS can hold large volume of data, and so we're going to run on top of HDFS. And also it's imperative that the zookeeper is running as well, because the hbase makes use of the zookeeper. And if you go to Hue, which is the Hadoop user experience, and click on the Hue menu, and there's a link here called hbase. So if you click on the hbase, it will list all the tables that are in hbase. At the moment we don't have any tables, so we'll be creating one via the code. You can also use hbase via the hbase shell. So you can create an hbase shell from the command line, and you can create new tables and so on. You can also create new table from this Hue menu here by clicking on the new table. So but for this tutorial we are going to create the new table while we write to hbase. So I'm going to double click on write to hbase code, and let's go through this code one step by step. Firstly, creating a configuration, and we are using the hbase API, hbase configuration.create. So these classes, everything to do with hadoop.hbase is coming from the hbase client that we added to the POM file. That brings in the hbase jar files. If you look at the Maven dependencies, you can see an hbase activation. So you can see the HTTP client here, Hadoop. You can see the hbase protocol here. You can see the zookeeper. And the hbase client 120 CDH 583 jar is here. So once you have all the jar files, you should be able to use the APIs. So firstly, within the try block, so the try block will have the auto closable, so the connection will be automatically closed once it's done with it. From the connection factory, we are creating a connection here. So before we do that, we need to have the URL to connect to the hbase that is running on Cloudera. So that, similar to Hive, it will be under etc hbase conf. You have something called hbase site.xml. There are a number of different ways we can do that. We can either set the HP configuration as parameter, or we can click on the URL here and add as a resource. And also you can, if you're running it as a Spark, you can provide it as a property, a configuration. So it's all listed in the tutorial we looked at earlier, step by step. There are different ways you can configure or connect to hbase. So in this case, if you are looking at the etc hbase conf hbase site.xml, you can go to a terminal window. So I'm going to clear out this first. So if I do pwd, I'm already on the etc /etc hbase and conf folder. If I do an lsltr, you can see there's a file called hbase site.xml. So if I do a cat hbase site.xml and I do more, pipe it, and there will be a property called hbase zookeeper quorum. That's the one tells you the name, the host name. In a cluster you can have multiple host names and they will be separated by a comma. In this case it's only a quick start, so there will be only one host name. So I'm going to go through here and look for the zookeeper. So the zookeeper node, zookeeper root server, here it is, zookeeper quorum. So this is the property that we need. So it's hbase.zookeeper.quorum and quickstart.cloudera is the host name. You can have comma separated values here, but in this case there's only one value. So you can provide hbase.addResource and provide the URL to the hbase site.xml, or to the hbase configuration you can set that particular property here, which is called hbase.zookeeper.quorum, and then you will get the connection to the hbase server that is running on the Cloudera. And then you create an admin object. From the hbase connection you get the admin, and you create a table name. So in this case I'm going to call the table name orders, and then from the hbase admin we can check if the table name already exists. If it doesn't exist, you can create a new table as shown here. And while creating a table, so hbase has the concept of row key, so everything is uniquely identified. A column family, and under column family you can have multiple columns. They're known as the qualifiers. So you can have 2 or 3 column families, and it's a best practice to have the column family as short as possible. So in this case I'm calling the column family I, which is for info, and then under I, which is a column family, you can have multiple columns like order name, order address, and so on. And these columns, each row doesn't have to have the same number of columns. So row 1 can have 2 columns, second row can have 3 columns, third row can have 4 columns. So they all basically like any number of name value pairs. So that's why it's called the NoSQL or columnar database. And unlike the normal SQL, the structured query language tables, which got a fixed structure, so if you have 5 columns, those 5 columns will go across all the rows. Here you can have variable number of columns. So here, once we get the table, so if the table does not exist, we create the table, and then we're creating a column family called I, and under that column family I'm having 2 qualifiers. The qualifiers are nothing but columns. One is order name and the other one is order address. And then we are creating a row key one. So in hbase everything you work with bytes basically. So here you can see all of these are byte arrays, and I'm calling 1 2 3. So order ID is going to be the row key. So the row key design is very important in hbase. hbase doesn't use any other additional indices. Everything is stored in the order of the row key, sorted by an alphanumerical order. So it's a lexicographically sorted. So all these are covered in the hbase interview questions and answers. So if you are interested in learning the hbase basics, then I would advise you to look at the hbase interview questions and answers. So here we are getting 1, 2, 3, which is a row key. Then we are creating two values. One is called John Samuel, that is the order name, and the address is 34XY Street, ABC Colony. And then here, so if you are going to write something to a database, you call it a put, and if you want to get something, you can either do get. So put and get basically work on the row key. So you put by the row key and then you add new columns to it. When you're doing a get, you do by the row key as well. But if you want to read other data, then by a column value or something, then you do a scan. So in this case, put 1 is equal to new put. I'm putting a row key one here, then adding two columns. The first one is the order name, another one is the order address. For both of them, you need to have the family and the qualifier. So in this case, family is I, and the qualifier is qualifier order name. And here the same, family is here, which is I, this I here, and the qualifier is the address, and then we are passing a value. So basically it's the name and a value here, and this is under the family, which is a column family, which is I. So name is the order name and value is the John Samuel, and qualifier order address is the qualifier or the column name, and 34XY Street ABC Colony is the value. And then you put it into the table.put, put 1. And then similarly there's another row key 2, and the row key ID is 456. You can see everything is converting from bytes to bytes here. And then we are only adding one column, which is Emma Thompson, which is the order name, and we are not adding any address to it. So as I said before, you can have a variable number of columns. You don't have to have the same columns in every row. And then I'm doing a table.put and put 2. So basically you can also have a list of puts. You can add all the puts to the list, and then you can do table.put and pass a list of those put values to store all the rows in one hit, as opposed to this is one call to the hbase and this is another call to hbase. So you can basically combine all the puts together in a list, and then you do a one table.put and you pass a list of put values. So that's what basically it's doing. So now if I run this query, we should be adding something to the hbase process. So here we don't have any table, we don't have any values inside. So this one, you can run it as a normal Java application. So I'm going to go up here and look at the write to hbase, right click on it and then say run as Java application. So it's going to run it and it finds if it can connect. So all your configuration has to be correct to be able to connect, and then it should execute these put commands and it's done. Now if I go into my Hue browser again and look at and refresh the screen, so Hue stands for Hadoop User Experience, and this should list one table now because you should have created the orders table. And then if I drill into the orders table, I should be able to see the rows and see one of them had two columns. So here the John Samuel order name and the order address is 34XYZ Street, ABC Colony. You can see everything is prefixed with I colon. That's the column family we use, I colon here. So this is basically the column family. And also there's a timestamp automatically because hbase keeps a different version. If I go and update this, and it will create another version on top of it. So it keeps a different versions of it, but it will only display the latest version. So it will show you the timestamp here. So this is 11/27/2017, 5:13:17 a.m. So that's the time it was basically saved. And the second row, this is a row key 456 and this is a row key 123, and this is Emma Thompson. So we only have the order name here. So now we have seen how we can write it to hbase. So the next step, now we will write a Java code to read this from hbase. So you can't use SQL with hbase because there's no SQL database. So there are two ways you can use the hbase API, the way we are using it at the moment. The next one is you can run a few commands in the terminal. So I'm going to look at the read from HDFS code. It looks very similar. So you create the configuration, you add the HDFS site.xml. Sorry, this is read from HDFS. So it should be read from hbase. So this is a read from hbase. The URL is hbase site.xml, and to the hbase configuration adding the resource which is the hbase site.xml, then creating a connection, and we're going to call the tables the orders because we have already created the orders. The family is I, this is the column family, so you always have a prefix I colon whatever the column name or whatever the qualifier, so you can call it a qualifier. Then I have two qualifiers, one is the order name, another qualifier is order address. So firstly I'm going to get by a row key. So there are two ways you can read data. One is by row key, just if you know the row key you just go and get the values based on the row key. The other one is if you want to do some scan based on the columns, you do a scan. So here the row key one is bytes 1, 2, 3. So create a get object here from the row key. Then you're doing table.get, and this is get by the row key. And then that gives you a result object, and to the result object you can get value. So when you're doing a get value, you got to do the family and the qualifier, which is the column name. In this case is order name, and same thing here, the family which is I, and the qualifier which is the order address. So this will get you these two values, but this will be byte array. So in order to convert a byte array to string so you can read it, we are doing a bytes.toString. So here we have been doing bytes.2bytes to convert a string to bytes. Here we are converting the byte results that we get back to string by doing bytes.toString. Then same way for the address as well. So this should retrieve with the values by row key. Next we look at the scan. So when you do the scan, we create an object called scan. We have to create a filter. There are different types of filters. You can also do row prefix filter and so on. In this case I'm going to use a single column value filter. So what this single column value filter does is it's going to look for a family and a qualifier name, and it's going to compare that with the value Emma Thompson. So basically we're going to look at the rows that have got the value of Emma Thompson as the order name. So we're here using qualifier order name, so it's going to retrieve everything by the order name. Then to the list of filters, so you can have multiple filters. You can have an AND filter, you can have or whatever, so you can add multiple filters, and then here you can say it must pass all. If it pass any means is an OR. If it must pass all means is an AND. So to the filters list I'm adding this single column value filter. Then I'm creating a filter list from that list of filters, and I'm saying the condition is must pass all. In this case you only have one condition. Then to the scan object, setting that filter list, and it is important to add the columns that you want because the hbase can have thousands of columns. So you don't want to scan and retrieve all the columns. So you want to list a few columns that you are interested in. So here, because I only have two columns, I'm interested in both the order address and the order name. Then from the table, getting a scanner. So this here doing a system.out line to say scanning, and then you do scanner.next, and you can get the value, and same way you do the bytes.toString, and you basically display the values, and then you close the scanner. So now if I run this, it's going to read the data from hbase. Run as Java application. So basically this is showing a standalone Java application, but in real world you will be calling the hbase from a Spark job. So calling it from Spark job is very similar. Then you'll be creating a Spark context, and then you'll be calling the hbase, getting the value, passing to the RDD or whatever, and so on. And you can also create Hive tables. So if you want to run SQL, earlier we saw that we can create Hive tables on top of HDFS. you can also create Hive tables on top of hbase and read the data that is already in hbase using SQL from Hive. So Hive will be basically running a MapReduce or a Spark or a test job, and it will be going to the hbase, retrieving the data, and it will be displaying. So when you create the table, the syntax will be slightly different to when you create a Hive table on top of the HDFS. So here you can see its order name is John Samuel, order address is this, then this is the get by key, and then it prints the scanning table, and then we do a scan, and in this case we are scanning by Emma Thompson, so this address is null. So now if I change this to John Samuel, to scan by John Samuel, it should be giving me the address as well. So I'm gonna go here to the scan and change this Emma Thompson to John Samuel, save this, and then I can run this again from here. So this time the value should be different because it's scanning for a different name, John Samuel. You can see it's making it a zookeeper. So here's the order name is John Samuel and the address is the same. We are also scanning by John Samuel, a column, and 34XY Street ABC colony. So it looks the same. So now we can read from the hbase browser. This is the data. So I refresh it again, it looks the same. So it's a very handy screen. So you can write different column filters, and you can filter, you can drop rows, you can create a table. So you can do a few operations via this hbase browser screen here. You can sort them, you can drop columns, and so on. You can also access hbase via the hbase, what is called the hbase shell. So I do Control-C out of here, clear the screen, and I'm going to type hbase shell. So in one of the previous tutorials, all the commands are given to run the hbase shell commands. In this case, I'm going to quickly go through a few commands. So I'll wait for it to start. So firstly, you can list all the tables by typing in list, which will list all the tables. So if I want to see what tables are there in hbase, I just type in list. See table, it says only orders, so we only have orders table. Now the next command I can type is I want to get from the orders table. It is important that everything you type in should be in a single quote. So if you don't put a single quote, it will not work. So I get orders, and then I'm going to put comma, and if I know the row key ID, which is 1 2 3, so I press enter and it gives me the value. So order ID address is 35XY Street ABC colony, value is John Samuel, and as I said before, everything will have a timestamp, so that's the timestamp of the column. So you can also run the single column value filter as shown in the earlier tutorial, and you can also delete a particular. So I'm going to do delete all, and then I'm going to say which table I'm going to delete from. It is important I put in the single quotes. So delete all orders, and then I'm going to say which row I want to delete. So in this case, say I want to delete 1 2 3, put a single quote here, and this should delete all the columns for that particular row with a row key of 1 2 3. So now if I come back here and do a refresh, the row key 1 2 3 should disappear. That means it had deleted all the columns under that particular row. So delete all is useful to delete the whole row. If you want to delete certain columns inside a particular row, you can do delete, then the name of the table in quotes, that is order, single quotes, and then the row key, which is 1 2 3, and then column family I prefixed by the column name, then it will only delete that particular column. So now the row number 1, 2, 3 is gone, so you only have 4, 5, 6 left. Now there is also another command that if you want to truncate the whole table, I can say truncate orders and press enter. You can also disable and then truncate, or you can truncate, which will disable the table first and then it will truncate it. So this should remove all the entries. So if I go and refresh this, now all the rows and all the columns should have gone. So it's all gone. You only still have the tables. So if I click on hbase back here again, I'm back on hbase. Now I can click on the orders. I can also drop here. So this will delete the table. It's confirming it and it's gone from here. So I can now run the code again, write to hbase, it'll create a new table, it'll run. So normally you don't delete everything unless it's really required. You keep appending new rows to it. So this is basically a quick tutorial on the hbase. So this is basically the video demo. In the above links, in the other tutorials, you have step by step how to write. This code should be there, how to read, and also what commands you can run on the hbase shell.